Something strange began long before anyone noticed it. Not with an explosion, not with a signal, but with a quiet discrepancy buried deep inside astronomical data. At first, it looked like noise, the kind scientists see every day and usually ignore. Tiny deviations in light, a slight mismatch in timing, numbers that were almost right but not quite. Telescopes across Earth had been watching a distant region of space, cataloging objects that barely registered as anything remarkable. No comet tails, no dramatic brightness, no obvious threat. Just a dark, fast-moving presence cutting through the background of stars. Then someone noticed the speed. It wasn't behaving like anything we knew. Its trajectory didn't curve the way gravity demanded. It didn't slow down. It didn't accelerate in a predictable way. It moved as if the universe itself wasn't pulling on it properly. At first, the assumption was simple: bad data. Instruments drift, sensors fail, software miscalculates. The easiest explanation is usually the right one. Except the same anomaly appeared again and again. Different observatories, different instruments, same result. Something was coming. As calculations were refined, its path became clearer. This object wasn't bound to our solar system. It wasn't orbiting the sun. It was passing through, entering from interstellar space, cutting across planetary orbits at a shallow angle, and continuing onward as if nothing here could stop it. Interstellar visitors are rare, but not impossible. Science had prepared for this idea in theory. What it hadn't prepared for was behavior that made no sense. The object showed no signs of outgassing, no ice vapor, no dust cloud, no visible tail. Yet, it was changing speed. That was the first red flag. By the time its existence became undeniable, it was already too late to observe it up close. The object had crossed a critical threshold, close enough to be measured precisely, but far enough that any sudden discovery felt like waking up halfway through a sentence. News didn't break immediately. There were internal discussions, quiet emails, late-night recalculations. Nobody wanted to be the one who sounded the alarm over a mistake, but as more data arrived, one conclusion became unavoidable. This wasn't behaving like a comet. It wasn't behaving like an asteroid. It wasn't behaving like anything humanity had ever recorded. The object didn't announce itself. It didn't glow. It didn't roar. It didn't threaten. It simply passed through our cosmic neighborhood with indifference, as if our sun, our planets, and our presence meant absolutely nothing. And that raised a question far more unsettling than danger. What kind of universe allows something like this to exist? Because whatever this object was, it wasn't just passing through space. It was passing through our understanding of reality itself. And once it did, nothing looked the same again. The moment scientists accepted that the object was real, everything changed. Its path was recalculated again and again. Not because the math was difficult, but because the results felt wrong. According to every known model, an object entering the solar system from interstellar space should behave in predictable ways. Gravity should bend its trajectory. Radiation from the sun should affect its motion. If it contained ice, heat should trigger outgassing, creating a visible push. None of that was happening. Instead, the object showed a subtle but measurable acceleration away from the sun. An acceleration that could not be explained by gravity alone. It was small, almost polite, but persistent. Enough to be undeniable. The first explanations were conservative. Perhaps it was an unusually shaped comet, releasing gas in a way we couldn't easily detect. Maybe it was spinning, producing thrust in a direction invisible to our instruments. These ideas were not unreasonable. Science always starts with the familiar, but each explanation collapsed under closer inspection. No gas plume was detected. No dust trail followed behind it. Spectral analysis showed nothing that matched known comet behavior. If it was releasing material, it was doing so without leaving a trace. That should not have been possible. As the object moved farther away, something else became clear. Its brightness fluctuated dramatically, far more than expected. That suggested an extreme shape, long, thin, perhaps flattened. Some calculations implied it could be 10 times longer than it was wide. Others suggested something even stranger, a structure shaped more like a sheet than a rock. Nature rarely makes things like that. By now, the internal language had changed. Emails no longer said object. They said anomaly, then visitor. Then, in some private conversations, something else entirely. Because when every natural explanation fails, the human mind reaches for uncomfortable alternatives. No one announced those thoughts publicly. That would have been irresponsible. But the silence itself was telling. Scientific caution had turned into something closer to unease. The object didn't rotate the way it should have. Its motion suggested stability without mass where mass was required. Its acceleration matched what you would expect from radiation pressure, the gentle push of sunlight, but only if the object had an absurdly low density, something more like a sail than a stone. That idea lingered, unspoken, at the edges of discussion. Meanwhile, the clock was running out. The object was already leaving. Every hour that passed reduced the amount of information we could collect. There would be no second chance, no follow-up mission, no closer look. Humanity had noticed the visitor too late, and yet, even as it faded into the darkness beyond the planets, it left something behind. Not debris, not radiation, doubt. Because if this object was natural, then nature was capable of things we had never imagined. And if it wasn't, then the implications were far more unsettling. Either way, the universe had just demonstrated that our models were incomplete, and the silence that followed was louder than any signal could have been. Something had passed through our solar system, and we still didn't know what it was. By the time the data reached independent teams around the world, the discussion had quietly intensified. This was no longer just about what the object was, but about what it wasn't. It wasn't slowing the way a comet should as material boiled off its surface. It wasn't tumbling chaotically like an irregular rock. Its motion showed intention-like consistency, even though no one was willing to use that word openly. Some researchers focused on what wasn't detected. No radio emissions, no thermal excess, no chemical signatures typical of ice or metal. In astronomy, absence can be more powerful than presence, and here the absences were stacking up. The light curve became the next battleground. As the object rotated, its brightness changed sharply and repeatedly, producing a pattern that looked almost rhythmic. This wasn't the gentle variation seen in asteroids. It was extreme. Models showed that to produce such a signal naturally, the object would need to be either extraordinarily elongated or unnaturally thin. And thin objects in space don't survive long. Interstellar travel is violent. Cosmic rays, micrometeoroids, and gravitational stresses shred fragile bodies over millions of years. Yet this object appeared intact, coherent, and stable after a journey that likely lasted longer than human civilization has existed. That contradiction troubled many scientists more than any exotic theory. A few teams began running simulations that pushed the limits of accepted physics. What if the object wasn't dense at all? What if it was hollow or structured? When radiation pressure from sunlight was applied to these models, something unexpected happened. The equations worked. A low-mass, high-surface area object would accelerate exactly the way this one did. No gas, no exhaust, just light pushing against it. That realization changed the tone completely, because radiation pressure isn't a new concept. Humanity has already proposed spacecraft that use it. Solar sails. Thin, reflective structures designed to move without fuel. The idea that nature might accidentally produce something functionally identical was uncomfortable. Still, no one rushed to conclusions. Extraordinary claims demand extraordinary evidence. And so far, all anyone had were correlations and coincidences. The responsible position was skepticism. But skepticism doesn't erase patterns. As the object crossed the outer boundaries of observation, one final oddity emerged. Its orientation appeared to remain stable relative to the sun, instead of randomly shifting as expected. That stability reduced thermal stress and maximized radiation pressure efficiency. It was, quite literally, the most convenient orientation possible. Chance can explain a lot, but chance explaining everything all at once began to feel strained. The visitor continued outward, slipping beyond the reach of our best instruments. No farewell signal, no final flare. Just a slow fading into the background of stars. Yet, its impact lingered, not because it threatened Earth, but because it challenged certainty. If this object was natural, then the universe was far stranger than we had assumed. And if it wasn't, then humanity had just missed its first close encounter with something built, not born. Either possibility was profound, and as the data archives closed and the telescopes turned elsewhere, one quiet question remained unanswered. Was this truly a random passerby, or something that noticed us and chose not to stop? As the object moved farther away, attention shifted from observation to interpretation. Data can be measured, but meaning has to be argued for, and that is where the real divide appeared. On one side were researchers insisting that history was repeating itself. Astronomy has a long record of misunderstanding first encounters. Pulsars were once nicknamed "little green men" because no one could explain their precise signals. Quasars were thought to be impossible. Even meteorites were dismissed as superstition until rocks literally fell at scientists' feet. From this perspective, 3 Atlas was simply the latest embarrassment waiting to be resolved by better models. But others weren't convinced. They pointed out that those past mysteries eventually fit into known physics. Here, the physics itself was being bent to accommodate the object. Take the acceleration again. When sunlight pushes on an object, the effect is incredibly weak. For asteroids and comets, it's usually negligible. Yet, in this case, radiation pressure alone could explain the motion, if the object had an extreme geometry. Something thin, something broad, something closer to a sheet than a rock. Nature doesn't favor sheets, ice fractures, dust aggregates collapse. Over millions of years in interstellar space, thin structures should erode, warp, or shatter. Survival requires mass and cohesion. And yet, this thing endured. Another team examined temperature data. As it passed closer to the sun, there was no sign of intense heating or outgassing, no dramatic thermal spike. Instead, the surface temperature appeared unusually well regulated. It warmed slowly and cooled predictably, as if heat was being distributed evenly rather than trapped. That again raised uncomfortable questions. Even a tumbling object would show hot spots and cold shadows. Uneven heating is unavoidable unless rotation is controlled or the structure is engineered to minimize gradients. No one said that out loud in official papers, but it appeared in the margins, in the tone, in the careful wording that avoided conclusions while circling them. Privately, discussions became more direct. Workshops and closed-door meetings debated whether the community was being too conservative or not conservative enough. Some worried that even entertaining artificial explanations would damage credibility. Others argued the opposite, that refusing to consider them would be unscientific. Meanwhile, the public narrative remained calm. Press releases emphasized uncertainty. Headlines softened language. The object was labeled unusual, enigmatic, poorly understood. But behind that language was unease. Because interstellar objects are rare, but they are not unique anymore. 3I Atlas was the 3rd confirmed visitor. Statistically, that meant there were many more passing through undetected. This one just happened to pass close enough, bright enough, and strange enough to force a reckoning. If this visitor was natural, then the galaxy is producing objects far outside our expectations. And that means our models of planet formation, ejection, and survival are incomplete. If it was artificial, the implication was even heavier. Not invasion, not contact. Something quieter and more unsettling, that we are not interesting enough to interrupt. A probe that passes through, observes silently, adjusts its course, and leaves without acknowledgement suggests a universe where intelligence exists, but interaction is optional. As 3I Atlas faded beyond meaningful study, certainty faded with it. The data would be debated for years. Papers would be written, rebutted, and revised. Careers would quietly hinge on interpretations made now. But one thing had already changed. Humanity could no longer pretend that every visitor from the dark would be simple, or safe, or easily classified. Some questions, once asked, do not go away. And this was only part of the story. By the time 3 Atlas slipped beyond the reach of continuous observation, the conversation had moved into a deeper, more philosophical phase. The object itself was gone, but the implications remained, echoing through the scientific community. One line of thinking focused on probability. Space is vast beyond intuition. Between the stars, trillions of objects wander freely. Debris from shattered planets, failed worlds, frozen remnants of ancient systems. From that perspective, it is statistically inevitable that some of them will be strange, extremely strange. Rarity alone does not imply design, but probability cuts both ways. To explain 3I Atlas as natural requires stacking multiple low-probability features together: an interstellar origin, an extreme shape, unusual reflectivity, non-gravitational acceleration without visible outgassing, structural stability over cosmic timescales. Each one, individually, might be acceptable. Together, they strain coincidence. This is where the discomfort truly lives, not in any single anomaly, but in their alignment. Researchers began asking a different question, not, what is it? But, what does it force us to reconsider? Because even if every artificial hypothesis were wrong, the object still exposed a gap in understanding. Either physics behaves differently under interstellar conditions than we thought, or our assumptions about natural object formation are incomplete. Some suggested that 3I Atlas might be a fragment of a larger structure, broken off long ago. Others proposed exotic materials, hydrogen ice, porous fractal aggregates, or ultra-low-density composites formed in extreme environments. Each explanation worked on paper, but none felt satisfying. They solved one problem while creating two more. Then there was the silence. Throughout the entire encounter, instruments listened, not casually, intensively. Narrowband scans, wideband sweeps, repeated passes at different frequencies. Nothing. To many, that was proof enough. No signal means no intelligence. But to others, the silence meant very little. Human technology already includes probes that don't transmit continuously. Some transmit only when commanded. Some store data indefinitely. Some are designed to avoid detection altogether. Silence does not equal absence. It only equals non-communication. And non-communication can be a choice. As months passed, 3U Atlas became a case study rather than an active mystery. Students analyzed it. Conferences referenced it. Review papers summarized it carefully, neutrally, cautiously. Yet beneath the academic calm was something new. A subtle shift. Astronomy had always assumed that if we ever encountered something artificial, it would announce itself. A signal. A structure. A clear deviation from nature. 3I Atlas suggested another possibility. That evidence might be ambiguous by design or indistinguishable without the right questions. Not a greeting, a test. If something passed through our system and we barely noticed, misclassified it, argued about it, and then let it go. What does that say about our readiness? Maybe the real story of 3U Atlas isn't about aliens or comets at all. Maybe it's about us. About how we interpret uncertainty. About how tightly we cling to familiar explanations. About whether curiosity outweighs fear, and whether humility can coexist with confidence. The object is gone, but the question it left behind hasn't faded, and it won't be the last time we're asked to answer it. As the discussion matured, a quieter realization began to take hold, one that had nothing to do with whether 3 Atlas was artificial or natural. The real shock was how little time we had. 3 Atlas was detected only months before its closest passage. That was with modern surveys, automated telescopes, and constant sky monitoring. And still, the warning was brief. If the object had been smaller, darker, or faster, it might have passed unnoticed entirely. That fact unsettled planetary scientists. Interstellar space is not empty. It is a highway. Objects move through it at tens of kilometers per second, and most of them leave no trace of their passing. 3I Atlas just happened to reflect enough light in just the right way for us to see it. This led to an uncomfortable thought. What else have we missed? The answer, almost certainly, is a lot. Some teams began modeling how many interstellar visitors pass through the solar system every year. The estimates climbed quickly, from a handful to dozens, then hundreds, depending on size. Most are too small or too dim to detect. Some may pass close to Earth without ever being seen. That realization reframed the debate. If 3I Atlas was artificial, it wasn't unique. It was merely the first noticed. And if it was natural, then nature is sending us far more messages than we can currently read. Either way, detection is the bottleneck. This sparked renewed interest in rapid response missions. Concepts that once seemed unrealistic were taken seriously again. Spacecraft on standby. Modular probes that could launch within weeks. Interceptors designed not to orbit planets, but to chase visitors. Because observation from afar has limits, images blur, spectra average out, models assume too much. To truly know what something is, you have to get close, touch it, sample it, measure it directly. 3. Atlas exposed how unprepared we are for that. By the time anyone seriously discussed interception, the window was already closing. Delta V requirements grew, fuel margins vanished. The object was leaving faster than we could follow. That missed opportunity may be the most important lesson of all. Not proof of aliens, not proof of exotic physics. Proof that our exploration mindset is still reactive. We wait, we observe, we analyze after the fact. But interstellar visitors don't wait for us. Somewhere out there, another object is already on its way in. It may be ordinary. It may be strange. It may challenge our models even more than 3A Atlas did. And when it arrives, the question won't just be, what is it? The question will be whether we're ready to meet it properly. 3A Atlas is gone, but it left us a deadline we haven't acknowledged yet. And this is where the story truly ends, not with certainty, but with a realization that changes how we see our place in the universe. 3. Atlas did not arrive with an explanation, a signal, or a warning. It came silently, followed the laws we thought we understood just enough to confuse us, and then left without looking back. That silence may be the loudest message of all. Whether this object was a rare natural fragment or something far more deliberate, the outcome is the same. Humanity stood at the edge of discovery and could only watch. We observed from millions of kilometers away, argued over models, questioned assumptions, and then lost our chance. No close inspection, no direct measurement, just data fading as the object disappeared into interstellar darkness. This encounter exposed a deeper truth. Our science is powerful, but it is still slow. Our curiosity is vast, but our reach is limited. The universe does not pause for peer review or wait for funding cycles. It moves forward, and sometimes it offers only a brief window before closing the door again. If 3I Atlas was natural, then nature itself is far more complex than we imagined, capable of producing objects that mimic technology so closely they force us to doubt our own categories. And if it was artificial, then the implication is even more sobering. Intelligence elsewhere may not announce itself. It may observe quietly, gather data, and move on, indifferent to whether it is noticed or understood. Perhaps the most unsettling idea is that this was not special at all. That interstellar space is full of travelers, and we simply lack the tools, the readiness, and the mindset to recognize them in time. 3I Atlas was detected by chance, studied in a rush, and lost forever. Next time, the margin may be even smaller. This is not a story about fear or invasion. It is a story about preparedness, about humility, about realizing that the universe is not centered on us and never has been. Something passed through our cosmic neighborhood, challenged our best explanations, and left us with questions instead of answers. And maybe that is the point. 3. Atlas did not come to threaten us or greet us. It came to remind us that we are still beginners, staring into a universe that is older, deeper, and stranger than our imagination. The next visitor is already out there, moving through the dark. When it arrives, the only question that matters is this: will we be ready to truly understand what we are seeing?